learn a bit of geography, and also this is going to be the first episode in the series of geography is fun. So let's start. Today's topic is going to be motions of the earth. So let's start. You all guys know about rotation, right? But this is for those guys who don't know about the motions, rotation and revolution. Let me okay now I'm just telling you rotation is the spinning of the earth around its axis. So let's imagine, think of something that spins, such as a Beyblade. Okay, I'm drawing a Beyblade over here. Okay, I know this thing doesn't look so good, but whatever. This thing, a Beyblade spins from a center point, and that center point is called the axis. So the Beyblade or top rotates around its axis or center, and that goes same for the Earth too. Okay, I'm enlarging it. This goes same for the Earth too. But the thing is that that axis is actually tilted. That axis is actually tilted. Let me just show you. Okay, let me just show you that axis actually tilted at a degree of 23 and a half degrees. 23 and a half degrees from the vertical plane. And you might wonder what is a vertical plane, but that's the topic for another video. And there's another thing called the orbital plane, which is just basically the line on which the Earth orbits around the sun. Okay. So from the orbital plane, it's actually 66 and a half degrees. But from the vertical plane, it's 23 and a half degrees. You see, so remember this fact. Okay, so now this is done. And for the next fact, it's going to be that the axis is always parallel is always parallel to n to the position of the axis in any position of the earth. It means that think of these two circles as the earth. These two circles are the earth, and both of these have their axis, but these axes are always parallel, and parallel lines are those two lines that never meet. And if you keep extending these two axes, they will never meet. So that's why it is called parallel line to any position of the earth, but it will be on its orbital plane. Let me just write it again. Orbital plane, that is. On the orbital plane. And I'm showing you the orbit. The orbit of the earth is like this, and over here is the sun. This is just a rough sketch. still, at least you get the idea, right? And now it's time for the next segment of rotation, that is effect of rotation. Effect of rotation. So first, this point you all know that rotation causes day and night. I don't need to explain this point so much, so I'm just leaving it right now. But there's a point that most of you might not know or you might have trouble. So that point is the orange and red diffused light that comes before and after sun before and after sunset and sunrise is called dawn, and and dusk. Remember this point. It will be very important. So now time for the next fact, that is rotation causes a centrifugal force at the center of the earth, which causes the bulge at the equator and the flattening of the poles. Okay, read this whole paragraph because it will take you around 30 seconds. Or pause the video, or I'm just waiting 5 seconds. 5, 4, 3, 2, 1. That's it. Now I'm going to delete it. Now it's time for revolution. Revolution is, I'm still writing it. Revolution is the earth movement around the sun on its elliptical orbit. Yeah, that's it for that is basically rotate revolution. Not much hassle. So time for let's just move right on to effects of revolution. revolution. So revolution, first of all, this point everybody knows. Still, I'm writing in revolution causes seasons. Yeah, because because when the earth revolves, it goes into different positions and receives different light, different amount of light at the both hemispheres. So the temperature at different places at the temperature differs from its position on the orbit, and also the temperature at the poles different have great difference. Meaning, if it is summer in the North Pole where I live, then it is winter in the South Pole. If it's spring in North Pole, then it's autumn in the South Pole. Not South Pole, but it's the Northern Hemisphere and Southern Hemisphere. It was a big error. Sorry, I'm very sorry. Don't write it in your exams. I'm still repeating it once more. If it is summer in the Northern Hemisphere, it is winter in the Southern Hemisphere. If it is spring in the Northern Hemisphere, it's autumn in the Southern Hemisphere. And then, and then the next point is revolution causes solstice, solstice and equinox. Okay, first let me explain what is a solstice. So basically, solstice is of two types: summer and winter. Summer solstice occurs on 21st June every year, and at that time days are longest in northern hemisphere, and days and nights and and nights are longest in southern hemisphere. Winter so this occurs on December, and Northern Hemisphere experiences Northern Hemisphere experiences longest nights, and hemisphere experiences longest days. Yeah, meaning both are just opposite of each other. And I really hate writing hemisphere, northern hemisphere, southern hemisphere because they're freaking long words. Okay, so that is it for solstice. Let me just clear the screen. Now time for equinox. Equinox is a Latin word which means equal days and equal nights. There are two equinoxes, spring and autumn. Rays of the sun fall vertically on the equator, and cause equal days and nights. Yeah. So that is it for now, and also I'm really tired. So Ash Greninja out.